Good morning, everybody. Syed Rubina, mechanical, GPW. So, in the last class, I have explained you about the hydraulic system of the shaper mechanism. ఈ హైడ్రాలిక్ సిస్టమ్తోనే మీరు ఎలా షేపర్ స్లాటర్ని చేయొచ్చు. I have explained you in the previous class. So, I'm going to explain you in the what is cutting speed, and depth of cut. This I am going to explain you in this class. So what is cutting speed? In a shaper is the average linear speed of a tool during the cutting stroke. It depends on the number of ram stroke per minute and the stroke length. The cutting speed of the shaper may be constant or the variable depending on the design of the quick return mechanism used. Cutting speed is nothing but it's the length of cutting stroke by time taken by the cutting stroke. Okay. మనకు length ఎంత ఉంది? I have already told you it is totally depend upon the ram length. కటింగ్ స్ట్రోక్ అనేది లెంత్ ఆఫ్ ద ర్యామ్ ఎంత ర్యామ్ లెంత్ ఉందో దాని మీద డిపెండ్ అయి ఉంటుంది. సో టోటల్లీ డిపెండ్స్ అపాన్ ద లెంత్ ఆఫ్ ద ర్యామ్ లెంత్ ఎంత ఉంది దాన్ని బట్టి ద కటింగ్ స్పీడ్ ఆర్ ద కటింగ్ stroke can be done. Until length of the cutting stroke by the time taken by the cutting stroke. Okay, ఎంత టైం తీసుకుంటుంది అండ్ ఆల్సో ఎంత లెంత్ ఉంది దాన్ని బట్టి ద కటింగ్ స్పీడ్ ఈస్ క్యాలిక్యులేటెడ్. Okay, if this cutting speed can be varied for the type of finishing you are doing, depth of cut you are taking. ఈ కటింగ్ స్పీడ్లోనే మళ్ళీ ఎంత డెప్త్ చేస్తున్నారు and also what is the shape you are making it, what is the for what tool, and also shape of the work. Okay, shape of the work, this all depends upon the cutting speed also. Since it is difficult to measure exactly time taken by the cutting stroke, the ratio between the return time, cutting time, and also number of the double strokes per minute or the RPM of the bull gear or considered for the calculating the cutting speed. Okay, RPM of the bull gear or considered for the calculating the cutting speed. Okay, let L is the length of the cutting stroke. M is the ratio between the return time to cutting time. The value of M as 2:3 impels the tool is working 3/5 of the time of the ideal stroke, and it takes the 2/5 of the time. Okay, M you can calculate like this. L is the length of the cutting stroke, and M is the ratio between the return stroke of the cutting time and the value of the machine 2:3 impels the tool. And small n number of the double stroke of the ram per minute. Okay, number of the double stroke of the ram per minute, and also V is nothing but cutting speed. Okay, here V is nothing but the cutting speed. According to the equation, cutting speed is equal to length of cutting stroke by time taken by the cutting stroke. ఓకే, పైన ఇచ్చిన దాన్ని బట్టి కటింగ్ స్ట్రోక్ అంటే కటింగ్ స్పీడ్ ఈజ్ ఈక్వల్ టు లెంత్ ఆఫ్ కటింగ్ స్ట్రోక్ బై టైమ్ టేకెన్ ఫర్ ద కటింగ్ స్ట్రోక్. చెప్పినట్టుగా టైమ్ టేకెన్ బై ద కటింగ్ స్ట్రోక్ ఇన్ మినిట్ ఈజ్ ఈక్వల్ టు లెంత్ ఆఫ్ కటింగ్ స్ట్రోక్ L per minute by cutting speed V is equal to M by Vx. So we can also take as like this, time taken for the cutting stroke. How to calculating the cutting stroke, length of the cutting stroke by and cutting speed. Okay, so when you calculate this also you can దీన్ని calculate చేసిన తర్వాత కూడా మీరు ఆ cutting speed అనేది calculate చేయొచ్చు. So it is very important to know the cutting speed and also depth of cut. Okay, this makes the very important thing for the cutting speed, feed, and also depth of the cut. So L by length of the cutting stroke by 1000 అంటే టైం ఎంత ఉందో దాన్ని బట్టి V అంటే నథింగ్ బట్ M is equal to time of the written stroke by time of the cutting stroke. Okay, then the what is the written stroke of the time? That is M into cutting stroke of the time, that is M into L into by L by 1000 into V, that is the cutting time ఉంటుంది, cutting length ఉంటుంది, cutting stroke. The time taken to complete in one double stroke is directly given L by 1000 into V plus M into L by 100 into V. So, sorry, there must be 1000. Okay, when you give this, E values ఎప్పుడైతే మీకు తెలుస్తాయో ఈ వాల్యూస్ తెలుసుకోవాలి అని అంటే ఫస్ట్ లెంత్ ఆఫ్ ద కట్ తెలుసుకోవాలి, దాని తర్వాత స్ట్రోక్ టైం తెలుసుకోవాలి, స్ట్రోక్ కట్ తెలుసుకోవాలి. సో ఇవన్నీ కూడా క్యాలిక్యులేట్ చేసినప్పుడు దెన్ ఫార్ములా అనేది వేసేసి ఎప్పుడైతే ఇవి క్యాలిక్యులేట్ చేస్తామో దెన్ ఇట్ ఈస్ వెరీ ఈజీ టు know the cutting speed, cutting length, and also time of the cutting written stroke ఎంత ఉందో అదంతా తెలుసుకోవచ్చు. That is equal to 1 by L into 1 plus M by 1000 into V. That is N is equal to 1000 into V by L into 1 plus M. Cutting speed V is equal to NL that is of 1 plus M by 1000 minutes per meter. So this is the thing which you need to calculate that. So machining time, how can you calculate the machining time? That is the LBFME. So we already know L means length of the ram stroke, B means breadth of the job, F means speed, M means ratio of the written time or to the cutting time, and V means the cutting speed. So these ఇవన్నీ కూడా మనం ప్రీవియస్గా నేర్చుకున్నవే. So when you know these all things, you can know that those all things easily. Okay, ఇవన్నీ మీకు ఎప్పుడైతే తెలుస్తాయో అవన్నీ కూడా ఈజీగా you can calculate and also you can write it easily. Okay, now total time of the double stroke and written time ఎంత టైం ఉంటుంది? B by F. ఓకే, రిటర్న్ స్ట్రోక్కి వాటికి టైం ఎంత తీసుకుంటుంది, ఎంత the total time taken to complete one double stroke is L by 1000 into V into 1 plus M. Okay, the total time of the double stroke received to complete the work is B by F, that is the breadth of the job by feed in mm. Okay, breadth of the job by feed in mm. Hence, time taken to complete the machine L into B into 1 plus M by 1000 into F into V. This F means feed and V means the cutting speed. Okay, L means the length of the ram and capital B means the breadth of the job. So by here you know how to compare and also how to write those all the stuff. And metal removal rate, what is the MRR? Metal removal rate, that is nothing but how much metal is removed for the one stroke. Okay, ఒక్క స్ట్రోక్కి మనకి ఎంత మెటీరియల్ అనేది రిమూవ్ అవుతుంది ఇన్ ద ఫార్వర్డ్ స్ట్రోక్. ఓకే, ఇన్ ద ఫార్వర్డ్ స్ట్రోక్ హౌ మచ్ మెటల్ ఈజ్ రిమూవ్, దట్ ఈస్ నథింగ్ బట్ FDNL into 1 plus M meters per cube by minutes. Okay, that is nothing but F means field, D means here diameter you can say, and N, small n means in the previous class I have already told you what do you mean by the small n also, that is the number of double strokes. Okay, number of double strokes you have taken, and also L means length of the ram. Okay, okay, after that where you have to MRR you have to find out it, that is I have told you F means speed, D means depth, N means number of double strokes, L means length of the stroke, M means nothing but return to the cutting time ratio. Here the average cutting time and also feed or shaper work have been shown in the table. Average cutting speed and also feed for the shaper work. Here the cast iron, mild steel and also brass. I have already told you for the different type of the materials you are having the different materials. So మెటల్కి మనకు డిఫరెంట్ టైప్స్ ఆఫ్ మెటీరియల్ అనేది ఉంది. దాన్ని బట్టి యూ నీడ్ టు కంపారిజన్ అండ్ ఆల్సో యూ నీడ్ టు రైట్ ద మెటీరియల్. ఓకే, for the different type of the material you are having the different type of the things. So here the high speed steel tool and also cemented carbon tool. So దీన్ని బట్టి you have to adjust that and you need to write those all things. Okay, here the shaping operations లో ప్రస్తుతానికైతే ఇవి చెప్తున్నాను. Now I am going to explain you this machining of the horizontal surfaces. So when you have the speed feed and also depth of the cut, when you have completed that and entering into the mechanical machining of horizontal surfaces, the surfaces is held securely on the table. Okay, the work surface is held securely on the table and the tool is fixed in the tool head. Okay, and the tool is fixed in the tool head with the minimum overhang, and as shown in the figure, the table with the fixed workpiece is raised closer to the tool. The length of the position and the stroke are adjusted. The stroke length and 20 mm and the longer than the workpiece stroke is adjusted, so that the starting about the 10 to 15 mm before the workpiece and the continuous about the 10 mm after the end of the cut. So how to adjust the workpiece and also how the horizontal workpieces are done, and in the down figure you can see that how the vertical workpieces are done. Here the horizontal workpieces are done and here the vertical workpieces are done. Here to do the vertical works, see here it is tilted to some angle. Okay, the work is tilted, the tool head is tilted to some angle, but here you need not to tilt the angle. Okay, here you need not to tilt the angle, only in vertical works only you need to tilt the angle. In horizontal thing you can make it in the directly. Okay, you can make it with the direct thing, you need not to tilt it. Okay, here you can make the direct thing. So far we have completed the shaper machine, shaper operations. So that see, this is the shaper thing, forward and return stroke operations, shaper machine, line diagram, clear diagram of line diagram of the shaper machine, and what are the main parts of the shaper machine. Here is the parts, explanation about each and every part. Parts of shaper, each and every part explanation. And see, I have written in the detail and also explained the each and every part. And this is the tool head, how the micrometer dial is used, how the tools can be done forward and also backward stroke, and the classification of the shaper, how they are classified according to stroke, according to the position, and also according to the driving, according to the table, how they are classified. And this is the shaper machine. how it is classified, mechanism, crank and slotted mechanism, how the mechanism takes for the forward and also backward stroke, how what is the larger cycle and also smaller stroke for the forward stroke and also return stroke, specifications of space shaper machine, and one more driving mechanism, hydraulic shaper, driving mechanism. With the help of the oil, and finally we have studied about the cutting speed and also depth of the cut, calculate how to calculate the speed, field and also depth of the cut, and also I have explained you the that is only what is a formula based for to calculate how the material is differ from one material to another material, and how the horizontal works, tilting time and also vertical times. So this is the thing which you have learned for the today's session. Okay, yeah, in the next class I'm going to explain you the slaughter machine and also planer machine, so that you will be completing today about the slaughter and also the planer machine. In the next class we are going to study about the slaughter, planer, broaching missions.